Hello, check. I request all of you, please take your seat as we are going to start with this session.
Are you saying something or?
No, I'm just starting.
Okay.
Okay, so ladies and gentlemen, it's now time to start the next session, and this will focus on digitizing farms for effective utilization of inputs. This session will focus on the need of digitizing farms in India, the potential benefits to both farmers and agribusiness players, as well as critical insights on the evolution of digital farms in India. The session will highlight the current practices, challenges, and opportunities, and the kind of partnerships that will be useful in further strengthening this concept. And for the same, I would like Mr. Salil Singhal, Co-Chair, CII National Council on Agriculture, Chairman and Managing Director, PI Industries, to take the hold as session moderator.
Thank you. Ladies and gentlemen, I know it's a very tough call post-lunch. At least I'm feeling sleepy. Given both my age and but I'm on a very interesting session, I think. I think the key challenge is really, and I think this particular session would address the first chain of the agri-value chain, vis-a-vis, that means the input side and how it gets to the farms. And I have to say that we are very fortunate to have a panel of experts with tremendous knowledge, understanding, and in-depth experience in this area. And I would not take much time, but I think the name of the topic itself explains what we want to talk about. I have Ms. Shani Kaisar on my left, who's going to be our next speaker. She is a chemical engineer and material science from Technion of Israel, 20 years of R&D experience. She won the Israel Leading Women Entrepreneur Competition Award, and she was declared the most innovative Israeli startup award for 2015, and has a lot of experience and understanding in this area. And she's helped 60 hot-size startups to work along. So I will not take much time, but request Shani to go and please make your presentation. Thank you. Come on, let's have a big hand, so I know that you're all here.
Good afternoon, India. I'm very happy to be here. It's my second visit only, but I hope there will be more to come. So, Solfi's vision is to make a billion of devices of Internet of Things autonomous. And this will be with its unique autonomous power and communication based on its solar battery. SolarChip is a small startup company was established in 2009. The first that invested in the company was the Office of the Chief Scientist of Israel. The technology is very unique and has a strong IP. And we are now in the stage of ramp up, and with the pilot that was successfully finished. So I am not going to elaborate on the IoT. This is just a vertical scheme that I'm presenting here of the IoT. So it's all about collecting data, taking it up, and then you have to do decisions. So SolarChip is in the very, very low level, but I believe we have a very high-level product. Don't make me wrong. So what do we have? What platform do we hold in our hands? This is based on the uniqueness of the solar chip. We're the first in the world that succeeded to integrate solar chip within the standard chip manufacturing process. As Professor Yossi Shacham, who is, I'm happy to announce, is on the advisory board, mentioned that the CMOS is the most used one in the chip industry. So our solar cell can be a part of the CMOS process. And this is where we got the first award from IDTech, which is the analyst group that gave us an international award on this achievement, because others tried to do this as well. But we didn't stop with the uniqueness of the solar cell. We continue to go up in the food chain. Why? Because in the IoT, it's a very complex world, and you want to have solution. So our product line today is based on two products mainly. One of them is giving you the solar battery. The solar battery can give you the power for 10 years. The only thing that we need is that we have light, indoor or artificial. Here you see in the bottom in the right, it's for outdoor. This is why it has a very special box, not our design, we just took from share, that can stand in a very harsh environment. In the left, you can see that this is just a PCB board. One of the uniqueness of the solar cell is that it can be attached to the board in the standard process, because it stands in high temperatures. And this makes our technology cost-effective. You can indeed fabricate millions of that because this stands in the standard assembly line. And this PCB piece you see has done in a standard process. This is the only solar cell in the world that can be attached in a standard process. In the other processes, you have to attach it by hand. At the left is the more advanced duration that I'm holding here, which includes also the communication. And this is, I would call it our high runner. So it includes the RF and communication, and you can see there here two outputs. One of them is for the sensors, and the other one is for the antenna. And all this unit is, again, can be stand in hazard condition. It's called the standard, which is IP65, which is for the environment. But our solution is generic. We penetrate in three, as a matter of fact, segments, but of course I want to focus here on agriculture. In agriculture, you can see one of our deployment. I'll just mention the other segments. It's smart city and the retail. Looking deeper to the agriculture, so this is the unit, and this today, I'm holding in my hand, it's one directional communication. Under development is the second generation, which will have bidirectional communication. So today, with one directional communication, we can either bring the data of the sensor to the cloud or to control an irrigation valve. And we already have shown our ability to open and close with this unit in a remote control and irrigation valve. We're working with several companies that are fabricating such valves, and they see it as a huge opportunity. But as I mentioned, the next generation will control both. It will be the whole solution. You will send the data from the sensor to the cloud, and with the cloud, you can see it on your app, and then you can decide when and where to open the irrigation valve. And we are having now an R&D project with a huge irrigation company, which is asking us to open, with one unit, 16 irrigation valves. And this is what is going to happen, hopefully. This will be deployed in next year, end of the first quarter in the US. Here are some examples of deployment. And it's, as you see, we finished pilots, and we are now ramping up in South America, in Europe, and in Singapore. You see other deployment scenes also in Israel. We are working together with ATP Lab. You will hear them later on. Just a very brief look on our unit, which is giving power to a waste management sensor. a lot of need all over the world and another problems. One of them, I think, is also related to India. We just met people that are interested, is to measure ground level water. And this is, again, is done in the same system with our solar tag. Another example is from smart parking, which is also a huge problem in the world. So companies develop such sensors that can identify where you have a car or not and send it to the clouds. Just here, I'm just showing our evolution, and you can see where we go up in the food chain, we give more benefits to our products. And also, if coming to price, one of the challenges new technology has to face always is pricing. And why is that? First, we compete batteries. Batteries are from the 19th century are here. So, of course, they are very low price. But batteries cannot last in the field. This is one thing. Second thing, we have to face production in low quantities, so everything is expensive. Even though, since we're holding on our end a very efficient product, which works in very low energy, and all the product consume very low power, the outcome is a very cost-effective product, and this is only the start. And the main thing is that we do bring autonomous activity to these IoT devices. Few words on our team. Here you see myself, the second founder, is now the CTO, Rami Friedlander, with very experienced in the semiconductor industry and so on. And I want to mention our also chairman, Dr. Isaac Scheinberg, which is well known in the semiconductor industry in the world. And last but not least, as I mentioned, Professor Yossi Shacham is on our advisory board. And to summarize, we are bringing a compact, green, reliable solution to the market. We have 7 pilots all over the world, 3 finished and ramping up. Patented technology, and now we create initial revenues and doing quick ramp up. Thank you, and I want to thank also Professor Gary from University of Tel Aviv, who gave me the opportunity to be here. Thank you.
Well, that's an amazing product. That's power for you, for our power-hungry villages. I think it was a very appropriate presentation for the needs of countries like India. Hopefully, we can build on this. And what amazed me is the sheer length and breadth to which this technology can be applied. Phenomenal. Thank you, Shani. I have now the pleasure to invite my old friend Jacob Mulam-Maron to talk to us and make his presentation on what he has done. He's the director of Kidum, the technology transfer organization of the ARO in Israel, which is the research arm of the Israeli Ministry of Agriculture. Prior to that, he was with the Deputy Director for Work Relations in the Ministry of Finance, and is now responsible for structural changes in the government sector at that time. Now he has held different positions, and is now basically looking to plug Israeli technologies to companies worldwide. Jacob, your turn.
Hi, it's a pleasure to be here, to meet again with the people that are becoming fastly our good friends. I'd like to say, first of all, thanks to Salil and to the CII for organizing and enabling us to be here. What I'd like to show you in this, in my presentation, is basically some of the technologies and how they're being applied, some of the challenges, and how some of them are overcome in actually bringing them to the field. In India, we'd have specific challenges to overcome, and I gave one example of that. So there's basically 4 technologies that are in different stages of being brought to bear in the market. And I think all of them are opportunities for working together. Just very short to see where the ARO is. I'm basically representing the Agricultural Research Organization, the main research organization for agriculture and food in Israel. What I'd like to show you is in the precision space what we're doing. For instance, just to give brief, you can see a field of onions, this in the desert in Israel. As you can see, there's variation, a lot of variation application. We all know that you can tell by precision ag to see the differentiation and measure it. We're trying to do the right thing in the right place at the right time, as was mentioned. So where are we? Basically, there's data collection, data processing, and storage. And then we have, basically our issue is the decision support systems. We try to bring the data from many different sources as much as possible to contact and be able to access all types of different data from any type of technology. That's basically a very important issue. And basically bring this to site-specific application with different distributors, okay? So, of course, there's different sensors from different ways. Some sensors on land will have to be cheaper to be applied wide scale, but it's getting there fast, as was mentioned before. Others are from the satellites and from air, which are even now becoming very cheap to apply. One example of using air machines is through thermal imagery. Basically, this is a simple graph. 90-something percent, I think it's 98% of all water brought into the plant is being evaporated from the plant. The plants don't hold the water, they bring it from the ground and lose it into the atmosphere. This process of losing water is measured by thermal imagery, okay? Through either, we're using a lot of either near or the thermal part of the infrared. Here we can see a field, as you see, with the eye you cannot see, like in the onion field, we saw the differentiation. Here with the regular pictures, you cannot see the difference in this field, but there is a big difference between this field. Basically, the difference is the irrigation regime. In one place, there's basically where we see the purple light, there's too much application of water. Basically in vineyards, like in this case, too much application of water, which was unintentional in this case. We measured it by, the farmer made a mistake. It basically leads to his wine grapes being unusable for the wine industry because they didn't have enough sugars, they didn't have enough taste, they were ruined by too much irrigation. Okay, so you lost water, but you also lost your crop. Here you can say the good crop it has the right irrigation. So you can see with thermal imagery, we have a quite good picture, okay? Now, not only can we use the thermal imagery for the whole scheme, we can also find where we have problems in the irrigation itself. Here you can see very clearly, we find through thermal imagery, we think that where we have the problems in the irrigation system, so we can fix them, we don't lose water, we don't have bad crop again. This is just an example, but if you want, from our point of view, we have to verify. We bring technology, we have to check it out, and then we have a big system of sending people. That's why, in this case, bringing technology from our point of view is more expensive than in other parts of agriculture because we have expensive technology to be used. And then before we miniaturize it and we bring it to bear, it's expensive because it's at the research stage. So we have expensive technology. We have to send lots of people to verify in field trials that everything actually works. So we measure, we make detection, we reach a high level of application. And then, basically, we can manage the system. Okay, I'm going through this fast. Here we have basically the plan. You have the field on my right. I think it's your right. And on the left, we basically have the regime for the farmer. How much to irrigate? You see less in the middle, where there's a lot of water anyway. And we have to irrigate more in different parts of the field. Okay? This is all through thermal imaging. It's all applied. Now, where's the benefit? We talked about, does it give a return? Now, here's a slide that shows we measured and we saw we get a lot of return. Basically, this was, I think, 2 years back in Israel. We measured this technology. We checked, cotton yields were very high at the time. We had a good year. There was high temperatures, and there were a high yield of around 6 tons per hectare. Basically, we found that using through thermal imagery, we reach 8 tons per hectare, just by good irrigation schemes and precision ag. So raising by 30% your yields is a return. Okay, that's a very significant return for very, very small, cheap input. The thing is how to bring it, of course, to bear to the farmer. We'll talk about this in a minute. The second thing, just to show, we worked nitrogen, in this case in potatoes, to see how to apply it. We checked inside a plot, so we have basically a similar plot. We found we can completely predict where there will be a deficiency of nitrogen in the next year. It's not what you measure today, how much nitrogen I have, it's what my nitrogen needs to be in the next year. Now this data, of course, is not only relevant for the farmer, but it's very, very important for the distributor of chemical inputs. They want to plan. Basically, the idea is that they will send the farmer telling him, this is what you're going to need this year, here's what you need, we're sending it to you already in advance. Basically, you have to plan it, you have to get it, but through this cycle, by the end of the year, you know how much nitrogen you're going to need for the crop next year, okay? So this is already ready. In the first case, we're working now in the thermal imagery with Netafim and with other companies, basically to fit the technology in to close the last gaps of the technology. The technology is going to be probably, you'll see it widespread on the thermal in the next few years. The second one I'd like to bring here, this is a different application. Now, we talked about the field. We talked a lot about the field, but precision ag is not only for the field. In this case, this is for post-harvest evaluation. When you have post-harvest evaluation, you have to know the quantities of your fruit if you want, especially for exports, or you want to get high value. You want to know if you have an apple, is it rotten inside? You want to know, does it have sugar, water, starch, oil content? These are important attributes. Basically, we have sorting machines working autonomously in many factories today, but they don't know how to see these attributes. Through near-infrared, we basically, together with a rather small Israeli company, we managed to make the selection lines. Eshet Eilon is working, there are a few people who know this company, Ardi. They're working a bit with a few collaborations in India. Basically, we can tell all the available data just by adding one more component into the line. So it's, again, not a very big problem because we already have sorting lines. We just add the component. We have more measurements. We don't need to sample. We save a lot of time in the press, in the way it's measured. Okay? Third one. In this case, we want to know if we have pathogens in the food. I don't know if you're aware, there was a big outbreak. Every few years, there's a big outbreak of food poisoning. Lots of people get hurt from this. And sometimes, from the company's point of view, they have to make a big recall. Some of the companies even get bankrupt. Okay? In certain countries, there's a big outbreak from a certain company. The company is bankrupt. This happened in Germany 2 years back, a big epidemic. They didn't know where it came from. They blamed the Moroccan growers. It turned out it comes from lettuce from Spain. The people who were there producing, they lost, the Spanish lost billions, basically, in fresh produce being sold to Germany, because Germany stopped buying from them for a while, until they were up to scale. So we can basically, today, we have methods, again, spectroscopy, that can manage this, and you can see in the production line to know exactly how much bacteria you have, which kind of bacteria, is it harmful, and we have a red flag, and don't need to recall, it's in real time, no need for sampling, no need for 2 years in the lab, 2 days in the lab to check if it's good or bad. Okay, that's just an example. Last one, real-time milk analyzer. We need, when we have in the milk production system, some of the qualities, again, are important. Knowing protein, fat, lactose, blood, which is showing if we have disease, and other indicators. Basically, we developed with a company called Afimilk this sensor. The sensor measures everything very efficiently. It's not used in India at all today. The reason why is this. It's basically used in the milking. And this, in India, you don't milk this way the cattle, right? They're basically, the milk is brought in by the farmers. What they don't use, they bring in, and then it's accumulated, assessed, and then it's transferred to the plant. The transfer process. This process is not the most efficient, I'll tell you, in my point of view anyway. There's ways to get much more efficient. Also, when you transfer it to the factory, there's loss. Some of the loss is not on purpose. Maybe the driver stopped and turned the truck off for an hour and stopped the cooling. Maybe they took out milk to use. Maybe they put water in. There's lots of things going on, okay? And this happens. So basically, if we take one of these machines, very simply, attach it at the beginning of the system where you actually collect the milk, you can also give the farmer an indication. It can be price indication. It can be, you can give the price according to quality or not, but you basically know what the farmer is giving you. You measure the quality at the beginning, you measure it when it goes into the factory, you divide the milk and send it to where it needs to be used. Right from the beginning, you know what you have. This is one of the issues. I just want to give you an example, and now I'll just summarize. Basically, what I'm trying to show is the technology is available. It has value. The point is, how do we bring it to bear in an efficient manner? In this issue, from my point of view, my objective here is to try to build the platforms with partners. And from my point of view, we're open to everyone. We're working very strongly with Tel Aviv. We're working with the CIO. We're working with with many companies here to try to build the platform to bring this technology to bear in a systematic manner, not to wait until something happens or someone uses it in some way. To do it systematically, it's done, it's there, now let's use it. Let's find the way how to bring it to bear. That's basically what I want to say. Thank you. Thank you very much.
Thank you, Jacob, for presenting the CT scanning and MRI of plants. And I think the milk quality on spot and fruit quality on spot detection, I think, are enormously valuable technologies. And now I have the pleasure to invite Aile Engelhard. He is the founder and CEO of ATP Labs, which aims to deliver digital tools for enhancing food production at scale. He served in various leaderships, including R&D and management roles at the IDF, startups, and Microsoft, and brings 13 years of experience in incepting, designing, and delivering award-winning online IT and big data platforms on global scale. Actually, his education qualifications have shaken me because he has studied philosophy, engineering, and computer sciences. Thank you.
Thank you very much. Hi, everyone. First of all, I want to thank CII for hosting us and for this for being such great hosts. And also a special thanks to Dr. Gary Zussman. Gary, can you raise your hand? Please, round of applause for Gary. Because Gary is literally building a bridge between people and bridging India and Israel so we can collaborate and innovate in this industry. So thank you very much, Gary. This is the first time for me in India. And actually the first time I'm traveling east from Israel. So I spoke to my wife yesterday and she asked me, okay, so how is India? You've never been to India. So I told her, I feel that I'm discovering new parts of my brain. I don't know if it's the curry or something, but I feel something different. The neurons are connecting and different thinking here. So as you said, my background is mostly in IT, building data-driven platforms, cloud platforms. And few years ago, about 2 years ago, I had this vision of bringing some of the online technologies and practices that we bring from the digital world to agriculture and farming. One part of my family, one grandfather came from Germany and he became a farmer in Israel. My other grandfather came from Iraq and he was an engineer. So I'm kind of trying to mix both things. And this is mostly a vision overview deck of how we see the future of digital farming and what we do in this space. So the mission of